our first example, we're given the graph of g of x, and unlike the colored papers that we had, the colored papers we had to create the graph ourselves. Sometimes on a textbook or a quiz, they give you the graph and they say, we don't know the equation, but we'll just use function notation to say it's some function that we don't know the equation of. But you can still take that graph, move it left, right, up, or down. So what we want to do in A, and again, I will color code here, I will do A in blue. We want to take this graph and sketch it after each translation, 4 units to the left, write an equation in terms of the function g, and state the domain and range for each function. So first of all, what's going to happen in a math class, and always happens to students in math class, is while we read the instructions, you generally don't listen. You are like waiting to see what's going to happen. So sometimes that causes you a problem on a quiz or a test, because on a quiz or a test, you have to do the next part on your own. And when you read the instructions, you're like, I don't know what to do, because there's words in there that you're unsure of. In this question in particular, okay, it says sketch the image graph. So this is words that we haven't used before. All that means, it's pretty simple, is just sketch the graph after you move it 4 units to the left. The new graph we call the image graph. But again, if we haven't paid attention to those words beforehand, they could cause us problems on a quiz. Because we go, do I know how to do this? I'm not sure what they mean. And then you start to be unsure how to do something, which is relatively easy. Like, what grade do you think they would struggle moving this picture 4 units to the left? How far back would we hit? Like 1, 2, 3, 4, 1, 2, 3, 4, 4. Okay. Would this be beyond something a grade 3 student could do? Or do you think in grade 3 you could do that? Would it be beyond grade 7? You could probably, grade 7, you could probably take that and move it 4 to the left. So the idea is relatively easy. I bet you grade 3 students could move things, count 4 to the left. No problem. Once those are done, we've joined it together, we've got our blue graph. Now the second sentence, here in particular, this comes up a lot. I'm going to double underline the in terms of. What does it mean when they want us to write the equation of the image graph, that's our blue graph, in terms of the function g? Whenever they say in terms of, that means you need to have the function g on the right-hand side of your equation. So I'm going to write this in terms of the function g. My new equation is going to be y equals, and since it has been moved 4 units to the left, that would be inside the function. The function that I have is the function g. I would write it as g of, and then inside x plus 4. So now this is what it means to write something in terms of. Sometimes the question just says in terms of x. Then you need an x somewhere on the right-hand side of your equation. This one said in terms of the function g. We need to have the function g on the right-hand side of our equation somewhere. And then finally it says state the domain and range of our function. Now to figure out your domain are your x values. I find it easiest to start with, does it have a smallest x value? So I go to the left side of my graph. Oh yes, it starts here at -5. The smallest x value is -5. Does it have a biggest x value? Yes. Biggest x value is 2. So I can write my domain starting with my smallest value and say that x is between -5 and 2. This style of writing it is called set notation. I could also write -5 to 2 like this, with square brackets to say that both -5 and 2 are included. This is called interval notation. So at the beginning of the year, I will often write both. And then after a while that we've sort of gotten used to both, I'll alternate. I'll sort of like, oh, let's do this one in set notation, this one in interval notation, just so that you get used to it. You get used to both of them. When a question asks you for the domain and range, you can choose. Do you want to write your answer in set notation, or do you want to write your answer in interval notation? So you have that choice, but it's good to know what both mean, because if you get a multiple choice question, and the answer is in a notation that you're not used to, it could throw you off. So now we also want to figure out the range, and the same style you found your domain, now you're thinking range. Do I have a smallest y value? Do I have a biggest y value? So smallest y value, 2. Biggest y value is 5. Or you could write it from 2 to 5. Well, just a reminder about cell phones, right? Cell phones are not to be on your desk or out. So if you have them on your desk, just put them away in your backpack or in your bag. And for B, we'll do B in green. Translation 1 unit up. I just take all of those red points, shift them 1 unit up, connect the dots, and draw my new green graph. The equation for my green graph. Now, in terms of G, up and down is outside of the function, so it'll be G of x plus 1. So again, that's written in terms of G. The domain, smallest x value is minus 1. Biggest x value is 6. Here is interval and set notation. Same thing with the range. Smallest y value is 3. Largest y value is 6. And then once we are done a question, okay, one of the things that's very important when you're doing math questions is that when you finish, you should read them again. Did we answer everything that was asked for, right? Here's the graph of G of x. Sketch the image graph after each translation. We've done the sketch. Write the equation in terms of the function G. I did that for the blue one. I did that for the green one. State the domain and range for each function. I did that for the blue one. I did that one for the green one. Good. I've done everything possible. But you will find on quizzes and tests, sometimes your brain will do this to you. You will start reading, you'll get to sketch, and you'll be like, yeah, I can do that. And you'll start sketching. And as soon as you're done the sketch, you will say to yourself, oh, good job. Let's go to the next question. And you might miss the write the equation part, or you might miss the domain and range part of the question because you got so excited when you finished one part, you moved on. So it's good practice in math to reread things. They often have special information at the end about rounding, round to 2 decimal places that you forgot already when you did the question. So reading a question over is important for math. Now for each of our questions, after we're done a question, what I'm going to get you to do is above question number 1, I want you to write the following numbers, 4, 5, 6, and 7. And after you've written down 4, 5, 6, and 7, I want you to turn to the homework, which is just after the lesson. I believe it's on starts on page 169, and circle the number 4, 5, 6, and 7. We will not have very much time to work in class, So tonight, when you go home, you're gonna look at the homework assignment and you're gonna look over all the questions that you circled, and in an ideal world, you'll get them all done. If you're busy, I would want you to read through them all and maybe say, oh, I should try this one because that one looks like I'm not quite sure. Or I think I know how to do this one. You should try that one. And the answers for each of the questions are at the end of the homework. You don't have to turn all the way to the back of the book. You just have to turn, after the very last questions, the answers are listed. So you should be checking your answers after you've done questions to make sure that you're getting them right. The worst thing, and I've seen students do this, they're like, I just did 30 questions in a row, and I did the same mistake 30 times in a row. Do you know what I'm really good at now? I'm really good at making that mistake. I will do that over and over again because I've practiced it for 30 times in a row. So you want to catch if you're making mistakes early so you don't develop bad